Hello students! Okay, we're gonna be solving these questions. I'm gonna read question number 1. 5 minus negative 9. And I notice here I have a subtraction. And I'm gonna look at my first digit. This integer is positive. And the second integer is negative. Now I'm gonna use the anchor chart on the right side and see if I have any example that has the same type of integers and the same operation. And the first section, they have just opposite signs. On the second option, the first number is negative and I need to be positive. But on this one, the first digit is also positive. Then they have a subtraction. And the second number here is also negative. So we can use this example. So I'm going to highlight question 1 in yellow. And I'm going to use the same color to identify what section of the anchor chart is going to help me to solve question number 1. And this is the reference, so I can use the same strategy and apply it to my question number 1. Then when you will be doing independent practice, use this anchor chart that we have in this video, guys. The first digit stay the same all the way. You see that, guys? What happened to the subtraction from this step to this step? It changed to positive, to addition. The subtraction, we changed it to addition. And what happened to the negative? Remember how it's negative, but it changed to positive. So what does that mean? It means that they kept the first integers exactly with the same sign. It means that they changed the subtraction into addition. See that, guys? And then also it means they change the second integer they're subtracting to its opposite. What is the opposite of negative 3? Positive 3. And then we add just like we always add. 2 positives plus 3 positives equals 5 positives. Because then we have all of them positives in here. You see that, guys? Great. So that's what we're going to do. We're going to keep the same sign on the first integer. We change the subtraction into addition. And we're going to change the second integer to its opposite. Like that. So the first number stays the same. In this case is positive 5. The subtraction is going to change into addition. And the second integer is going to change to its opposite. What is the opposite of negative 9? Totally correct. Positive 9. That's how we subtract integers. Great. Now that we have addition, it's easier. 5 plus 9, positive 14. Great. Okay, so now let's do example number 2. On example number 2, I notice that I start with a negative integer. The operation is a subtraction. And then the second integer is positive 7. So I'm going to look for my examples and see. And I'm going to highlight this in pink. And do you find any example that has the same situation? Negative subtracting a positive. A negative subtracting a positive. Yeah, so this one will be our example. So I'm going to highlight this in pink. Like this. And I notice my first digit is negative. The operation is subtraction. And the second digit is positive. And they apply the same rule that I apply on the other example. We keep the first one. We change the addition into subtraction. And then we do the opposite. See that, guys? And then the way they did it, they kept the first negative 2. They changed the minus to addition and the 3 to negative 3. Great. And now that we have it as an addition, we just represent the addition. Negative 2, negative 3. All of them are negative, and the answer is negative 5 because all the chips are negative. Great. So we're going to be doing the same idea here. We keep the first digit, we change the subtraction into addition, and we change the sign of the second digit from positive to negative in this case. So keep the first one, negative 12. Change the subtraction into addition and get the opposite of the second digit. What is the opposite of positive 7? Negative 7. Excellent. Now here you notice that all of this, look at this example that we have here, guys. All of this will be negative. It will be like combining 12 negative chips with 7 negative chips. Remember how we add opposite signs? The answer is going to be negative. And it's just like adding regular numbers. What is 12 plus 7? 19. Great. So the answer is negative 19. Awesome. Let's do example number 4. For this example, I'm going to be using this bright green. And on this example, I have a negative, we have a subtraction, and then we have a negative. Let's look at the leftover examples that we have. And on this one, we have negative 2, subtracting, another negative. So this is the example that we're going to do. And looks like we keep applying the same rule. You see, guys, keep, change the subtraction, and get the opposite. So all the way they kept the negative 2 first. You see that, guys? Then the subtraction changed to addition, and the opposite of negative 3 is positive 3. And that's what they did in the model. Then they represent these 2 negatives here with these 2 negatives here, and then 3 positives with 1, 2, 3 positives. 0 pairs that cancel out, and then the answer is positive 1. The answer here is positive 1. And if you can predict the sign, because when we got to this step here, we noticed that one that we got more chips is the positive. So that's why our answer is positive. And for this example, I'm going to highlight it in green. Bright green. So let's do the same rule, guys. We keep the sign of the first integer. We change the subtraction into addition, and we get the opposite of the second integer. Great, let's do it. The first one stays the same, it stays at negative 12. The subtraction changes to addition. And let's get the opposite of negative 5. What is the opposite of negative 5? Positive 7. Great. Now we're adding opposites. Adding opposites is like subtracting. What we do here, we keep the sign of the integer that has more chips or the integer that has more absolute value, which is the same idea. So which one will have more absolute value or more chips? The 12, because it's negative 12. So the answer will be negative. And now I'm going to subtract these two numbers like any regular numbers. What is 12 minus 7? That's going to be a 5. Great. So the answer for this question 4 will be negative 5. Great. Okay, so now we're going to do number 5. Question number 5, we have a positive number. Then we have subtraction. And then we have another positive right here. And that should be the example on the bottom, right? Okay, so for this one, I'm going to use red. So it will be this one right here on the bottom. Okay, so my first digit is positive. The operation is subtraction. And then my second number is positive. And I notice here we keep applying the same rule. We change the sign and we get the opposite. So we keep the 2, keep and keep. We change the subtraction into addition, great. And then we get the opposite of positive 3, which is negative 3. Then we add like we add any operation with integers. We have 2 positives, 1 and 2. Then we got 3 negatives, 1, 2, 3. Then they're gonna cancel out the 0 pairs. And what we said is if we have opposites, it's like subtracting. What is 3 minus 2? That's gonna be 1. Then the sign will be the one that has more absolute value. In this case is negative 3. So the sign is negative because then on that one we have more chips, like the example that we have right here. Great, guys. So let's apply those rules in here. We have positive, we change the subtraction, and then we're gonna have to get the opposite of the second number. So right here, this will be 46. The subtraction changes into addition. And now we're gonna get the opposite of positive 49, which is negative 49. When we have opposite signs, we're gonna keep the sign of the number that has more chips, if we use a chips model, or the one that has more absolute value. Which number has more absolute value? Negative 49. So our answer is gonna be negative. Great. Now, if we have opposite signs, we subtract them. What would be 49 minus 46? The answer is 3. And we already predicted the sign of the answer. Great, guys. We found all our answers. And remember, when we're using subtraction of integers, use the property of the integers on where we can rewrite our subtractions into additions, and then apply the same rules of addition that we learned in the first video. Thank you, guys.